Download this code from codegive.com, link in the description below. Configuring TCP state bypass in FMC v6.3 and beyond, a comprehensive guide. TCP state bypass, also known as TCP normalizer, is a powerful feature in Cisco Firepower Management Center, FMC, that allows you to normalize TCP traffic by dropping out-of-order packets, retransmissions, and other anomalous TCP behaviors. This can be crucial for improving security posture and preventing evasions that exploit weaknesses in how applications handle unusual TCP sequences. However, it's essential to understand its impact, as aggressive enforcement can disrupt legitimate applications. This tutorial will guide you through the configuration and application of TCP state bypass in FMC, covering the following aspects. 1. Understanding TCP state bypass ****. What it does TCP state bypass normalizes TCP traffic by enforcing strict TCP sequence number and acknowledgment number expectations. It aims to eliminate TCP anomalies that could be exploited by attackers or cause issues with certain applications. It can drop out of order packets packets that arrive out of sequence are dropped, preventing attackers from reassembling malicious payloads using fragmented out of order packets. Drop retransmissions legitimate retransmissions, due to network congestion, etc., might be dropped if deemed excessive by the strict policy, which can be tuned. Enforce strict TCP sequence /ACK number validation the policy verifies that sequence and acknowledgement numbers align precisely with the expected TCP window. Handle TCP option anomalies invalid or unexpected TCP options can be discarded. Drop TCP FIN/RST anomalies maliciously crafted FIN or RST packets intended to prematurely terminate connections or cause denial of service can be mitigated. Why it's important improved security defends against evasion techniques and malicious TCP-based attacks. Application stability prevents issues caused by applications that are sensitive to unusual TCP behaviors. Reduced network congestion dropping unnecessary retransmissions can alleviate network congestion. Caveats potential application disruption overly aggressive TCP state bypass settings can lead to legitimate application malfunctions due to dropped packets. This is the most significant risk. It's crucial to test extensively and implement selectively. Performance impact the inspection and normalization process adds overhead, potentially impacting performance on high-traffic interfaces. 2. Prerequisites FMC access you need administrative or security policy editing privileges in the Firepower Management Center. Managed device ensure that you have at least one Firepower Threat Defense (FTD) device managed by the FMC. Understanding of TCP/IP basic knowledge of TCP sequence numbers, acknowledgement numbers, and TCP flags is beneficial. Network topology knowledge a clear understanding of the network topology to identify where TCP state bypass is most effective and safe to apply. Testing environment a dedicated testing environment is strongly recommended before deploying TCP state bypass in a production network. 3. Configuration steps in FMC, v6.3 and beyond. Step 1. Create or modify a network analysis policy, NAP. Network analysis policies define how the FTD analyzes network traffic. TCP state bypass is configured within a NAP. 1. Navigate to Policy-Access Control-Network Analysis Policy. 2. Choose an existing policy or create a new one. Asterisk existing policy. If you have an existing NAP that you want to modify, select it and click Edit. New policy. Click New Policy. Give the policy a meaningful name, example strict TCP normalization. Set the default actions for file and network discovery, usually none. 3. Base policy. Consider using a predefined base policy from Cisco. This provides a good starting point. Options include balanced security and connectivity, good general purpose. Security over connectivity, more strict, potentially impacting performance. Connectivity over security, less strict, prioritizes application functionality. Maximum detection, most aggressive, use with extreme caution. 4. TCP stream configuration. This is where you'll configure TCP state bypass. Within the NAP, navigate to the TCP stream configuration section. 5. Edit the TCP stream configuration. Click the Edit button. This opens the TCP stream configuration window. Step 2. Configure TCP state bypass options. In the TCP stream configuration window, you'll find the settings for TCP state bypass. These settings control the behavior of the normalization process. 1. Enable TCP state bypass. Check the box labeled Enable TCP state bypass. 2. Configuration tabs. You'll see several tabs that allow you to fine-tune the TCP state bypass behavior. General. Maximum TCP queue size. The maximum number of packets that can be queued for reassembly and analysis. The default is usually adequate, but in heavily congested networks, you might consider increasing it. A larger queue consumes more memory. Maximum segment size. The maximum number of bytes that FTD can expect in a TCP segment. Exceeding this value will drop the packets. TCP window scale option. You can enforce the use of this option by checking the appropriate checkbox to enforce that a window scale option should be seen. TCP state. Strict enforcement. This is the core of TCP state bypass. By default it will be enabled. Validate sequence numbers. Enforces strict validation of TCP sequence numbers. Enable this. Validate acknowledgment numbers. Enforces strict validation of TCP acknowledgment numbers. Enable this. Drop out of order packets. Drops packets that arrive out of sequence. Enable this. Drop retransmissions. Drops packets that are retransmissions of previously sent data. Enable this, use with caution. Dropping legitimate retransmissions can disrupt connections, especially in lossy networks. Consider the exempted retransmissions option discussed below if you enable this. Drop segment overlapping. This can happen, and is generally an indication of a broken TCP connection, so it can be useful to block these segments. Maximum segment overlap. Allows you to configure what the tolerance is for packets overlapping. The default is 0. Exempted retransmissions. This crucial setting allows you to configure thresholds for retransmissions before they are dropped. This is vital to prevent disrupting legitimate applications. Maximum number of retransmissions allowed. The number of retransmissions allowed within the retransmission window. Retransmission window, milliseconds. The time window in which the retransmissions are counted. Minimum retransmission RTO, milliseconds. Minimum round-trip timeout allowed. TCP flags. *SYN flooding protection*. The setting is crucial to protect from SYN flood attacks that attempt to overwhelm a server. Excessive SYN retransmissions. Set the maximum allowed SYN retransmissions before a connection is dropped. Drop bad TCP flags. Drops packets with combinations of TCP flags that are considered invalid or malicious. Common options include *SYN plus FIN, *SYN plus RST, *FIN plus PSH, *FIN plus URG. Drop packets with no flags. Drops packets that lack any TCP flags. TCP options. Strict enforcement of TCP options. Can enable stricter enforcement of TCP option checks for maximum security. Drop packets with bad options. Drops packets containing TCP options that are considered invalid or malicious. Common options include timestamp option with bad values, MSS option with bad values, SAC option with bad values, unknown options. 3 recommendations. Start with a lenient configuration. Begin with validate sequence numbers, validate acknowledgment numbers, and drop bad TCP flags enabled. Leave drop retransmissions disabled initially. Monitor logs and metrics. Carefully monitor the FTD logs and connection events for any dropped packets or disrupted connections. Gradually increase strictness. If no issues are observed, gradually enable drop retransmissions and fine-tune the exempted retransmissions settings. Use exemptions for specific applications. If a particular application is affected, create a custom NAP and exempt that traffic from the strict TCP state bypass policy. See Step 5, apply the NAP to access control rules below. Step 3, apply the network analysis policy to an access control policy. The network analysis policy must be applied to access control rules to be effective. 1. Navigate to policy-access control policy. 2. Select the access control policy. Select the policy to which you want to apply the NAP and click Edit. 3. Edit or create an access control rule. Edit an existing rule. Find the rule that applies to the traffic you want to protect and click the Edit icon. Create a new rule. Click Add Rule. Name. Give the rule a descriptive name, example TCP state bypass, web traffic. Action. Set the action to allow or trust depending on your security requirements. For network analysis. In the access control rule editing window, select the inspection tab, or similar depending on your FMC version. 5. Network analysis policy. Choose the network analysis policy you created in Step 1 from the network analysis policy drop-down menu. 6. Save the rule. Click Save. 7. Repeat for other rules. Apply the network analysis policy to any other access control rules that need TCP state bypass protection. Step 4, deploy the changes. After configuring the NAP and applying it to the access control rules, you must deploy the changes to the managed FTD devices. 1. Click Deploy in the FMC. This initiates the deployment process. 2. Select the devices. Choose the specific FTD devices to which you want to deploy the configuration. 3. Start deployment. Click Deploy. The FMC will push the new configuration to the selected devices. 4. Monitor the deployment. The FMC will display the status of the deployment. Ensure that the deployment completes successfully without any errors. Step 5, monitor and tune. After deployment, it's crucial to monitor the network for any issues caused by TCP state bypass. 1. Check FTD logs. Examine the FTD logs for events related to TCP state bypass. Look for messages indicating dropped packets or disrupted connections. To monitor connection events *, the FMC provides detailed connection event information. Filter the events to focus on connections that are subject to the TCP state bypass policy. Look for signs of disruptions. 3. Application testing *, thoroughly test all affected applications to ensure they are functioning correctly. 4. Adjust configuration *, if you identify issues, adjust the TCP state bypass settings in the NAP to be more lenient. For example, you might need to increase the maximum number of retransmissions allowed or disable drop retransmissions altogether for specific applications. Code examples: illustrative, directly applying configuration via CLI isn't the standard method in FMC, which uses the GUIN API. While you primarily configure TCP state bypass through the FMC's GUI, understanding the underlying concepts can be aided by considering theoretical CLI equivalents, for a hypothetical direct configuration on the FTD. * hypothetical CLI example, illustrative only. * policy map type inspect TCP _normalization_policy, defines a TCP inspection policy map. * TCP state bypass, enables TCP state bypass. * validate sequence numbers, validate acknowledgment numbers, enforces strict validation. * drop out of order, drops out of order packets. * drop retransmissions max retransmissions 5 window 1000, drops retransmissions, but allows up to 5 retransmissions within a 1000 milliseconds window. This is an example of a configuration that allows some retransmissions to mitigate disruption. * drop bad flags sinfin sin rst fin psh, drops packets with combinations of TCP flags that are considered invalid or malicious. * policy map global _policy, class inspection _default, inspect TCP normalization_policy, applies the policy map to the global policy for inspection of all TCP traffic. * service policy global _policy global, activates the global policy. Important considerations *. Application compatibility * before deploying TCP state bypass, thoroughly test all applications that will be affected by the policy. Some applications might be sensitive to strict TCP enforcement and might require adjustments to the policy or exemptions. Applications using techniques like TCP splicing or complex TCP handshakes can be particularly susceptible. Network conditions The effectiveness and impact of TCP state bypass depend on the network conditions. In lossy networks with frequent retransmissions, a strict policy can significantly disrupt legitimate traffic. Performance TCP state bypass adds processing overhead to the FTD. Monitor the device's CPU and memory utilization to ensure that the policy is not negatively impacting performance. Logging and monitoring enable detailed logging for TCP state bypass events to facilitate troubleshooting and policy optimization. Incremental deployment implement TCP state bypass in a phased approach, starting with a small subset of traffic and gradually expanding the scope as confidence grows. Example scenario: protecting a web server. Let's say you want to protect a web server from TCP-based attacks. 1. Identify the traffic *, determine the access control rules that allow traffic to the web server, example destination port 80 and 443. 2. Create or modify a NAP *, create a new NAP specifically for web server protection or modify an existing one. 3. Configure TCP state bypass * in the NAP, enable TCP state bypass with the following settings. Enable validate sequence numbers. Enable validate acknowledgment numbers. Asterisk enable drop bad TCP flags. Asterisk leave drop retransmissions disabled initially. 4. Apply the NAP. Asterisk apply the NAP to the access control rules that allow traffic to the web server. 5. Monitor asterisk monitor the FTD logs and connection events for any issues. If you observe problems, consider enabling drop retransmissions with carefully configured exempted retransmissions settings, or selectively exempt the traffic to the web server from the TCP state bypass policy by using a separate NAP with less strict settings. Troubleshooting asterisk. Asterisk dropped connections. Asterisk if you experience dropped connections after enabling TCP state bypass, review the FTD logs to identify the cause. Common reasons include dropped out of order packets or excessive retransmissions. Adjust the policy accordingly. Asterisk application malfunctions. Asterisk if an application malfunctions, temporarily disable TCP state bypass for that application to isolate the problem. If the application works correctly with TCP state bypass disabled, investigate the application's TCP behavior and adjust the TCP state bypass policy accordingly. Asterisk performance issues. Asterisk if you observe performance degradation, monitor the FTD's CPU and memory utilization. If resources are heavily utilized, consider reducing the scope of the TCP state bypass policy or upgrading the FTD hardware. Conclusion asterisk. TCP state bypass is a valuable tool for enhancing network security and improving application stability. However, it's essential to understand its potential impact and to implement it carefully. By following the steps outlined in this tutorial, you can effectively configure and apply TCP state bypass in your Cisco Firepower Management Center environment while minimizing the risk of disrupting legitimate applications. Remember to test thoroughly, monitor the network closely, and adjust the policy as needed to achieve the desired balance between security and functionality. Good luck.